Hey guys, you've got your quiz coming. It's going to be Friday. So I'm going to do one more video. This is going to be for the second review sheet, the one I passed out today being Wednesday. So hopefully this will be all you need. Tomorrow you can ask a few more questions in class, and then Friday's going to be go time. But looking here, periods 2 and 3, I fixed this up a little bit from how I gave it to you. I didn't mark that point C was the center of the circle. Probably you guys assumed that that little dot right there was the center of the circle, but that is important to know because, you know, if you know that point C is the center of the circle, then you know that this line is a diameter, which means you know that these two arcs over here have to add up to 180 because they form a semicircle. So basically, you're given this 78, and you can use that 78 to figure out x, because you know that the x plus the 78 has to equal 180, because it's a semicircle. So you subtract, and you get 102. So that's x. By the way, on your quiz, it'll be really obvious what you're solving for. You'll see a little space that says x equals y equals, and obviously that's what you got to find. So we just found that x was 102. Now you got to find y, and y is an inscribed angle. So on our little list of rules, this rule about an inscribed angle, I feel like that's rule number 3. You guys can check in your packet, see if I'm right. But we know that inscribed angles are just supposed to be half of the measure of the arc that they cut. So technically you should be showing me some work. So you just at least say y equals half of 102. I'm not asking for a lot, just actually write that down on the paper somewhere so I know what you're doing, and then give me the 51. There, that's it for number 1. Let's do 2. So for 2, you're now seeing a different kind of angle. You've got this blue line, and because that line cuts through the circle in 2 places, it's called a secant line. Then you've got a second secant line, and of course those 2 secant lines are forming these 2 intercepted arcs. We've got this 100-degree arc up here, and we've got a 32-degree arc down here. And the only thing here that you're solving for is y. So once you find y, you're done. And the rule for this kind of angle is that the angle is going to equal half of the big arc minus the small arc. That's our rule. And that feels like rule number 5 to me. I don't know. I don't really know what the numbers are. But the rule for sure is that this angle is the arc minus the arc chopped in half. So that means for us we're going to be finding y by doing 1/2 of the big arc, which is 100, minus the smaller arc, which is 32. So that's going to give us half of 68, which is 34. And that's it for number 2. So here's 3. So for number 3, this one probably wants to be a little bigger. And again, there's a whole bunch of extra words that I added in. So you guys didn't have these words before. But now, I'm being really clear when I tell you that line AD is a tangent line. And remember, a tangent line means it hits the circle only once. So we're tangent to circle B at point A, and we're tangent to circle C at point D. So we had a rule that says that the radius drawn to the tangent line is perpendicular. So you know that angle right there is 90 degrees. And you know this one is 90 degrees too. And you also know that this one right here is 80, right? So the only real circle theorem that you had to know here was the one about the radius being perpendicular to the tangent line. But now we kind of switch over to the fact that we've got a quadrilateral. And we're supposed to know that all the angles of a quadrilateral are always going to add up to 360. So if you know that this is 90, and if you know that this is 90, and if you know that this is 80, and then you have to solve for W, then we can just use that rule that says that W plus 90 plus 90 plus 80 has to equal 360 degrees. So then you just solve. So the 90 and the 90 make 180, plus another 80 is 260. So now subtracting 260 leaves you with 100. And that's it. So again, somewhere on your quiz you'll see W equals. And that's the only thing in this problem that you had to solve for. So now that we know that W is 100, you're done. That's another one down. Let's try 4. Now for 4 you got 3 different things to solve for. So for 4 we got to find x equals, we got to find y equals, we got to find z equals. But that's it. Once we have those things, we're good. So what do we know? The only thing we really know is that this arc right here is 84. And then we know that these lines are parallel. All right, well, let's take the thing we know and use it. If this thing's 84, then I can't solve for x or y or z, but I can at least find this inscribed angle. So let's do that. That inscribed angle will be half of the 84. So that's 42. And I'm realizing I lied. A second ago I said we can't find x or y or z, but yeah we can. Because C is again the center of the circle, which means arc x and the 84 have to add up to 180 because they form a semicircle. So we can find x right now. Actually, we know that x is going to be 180 minus the 84. So x is going to be 96, and that's one thing down. Now I think the only thing we can do now is find that inscribed angle at 42. And hopefully you remember that we just said this chord and this radius are parallel. So if you've got parallel lines, you better remember that when a third line comes cutting through them, it creates that whole bunch of congruent angles. Let's just talk about the one that matters. So the one that matters is the pair of angles that sort of form this Z-shaped bit. And then you would know that this angle and this angle have to be congruent because they're alternate interior angles. So, since this guy's 42, we can rest assured that y is also 42 because they're alternate interior angles. Okay, and so now that y is 42, well, y is a central angle, so we can say that the arc that it cuts is 42. And then we can see that the 42 and arc z together would be the other semicircle that got chopped by this diameter. So we know that z is just going to be 180 minus the 42. So that's going to be 138. And then we're done with that one. So we can move on again. These could maybe be a little bit bigger. Or maybe they're fine. So what do we got here? Just an x and a y. Okay, so this is another one of our theorems. This one, it's either rule 6 or 7, I think. It's from sort of the end of our packet. But we had this rule that talked about what happens when a radius is perpendicular to a chord. And so hopefully that you remember a couple of things happen. One thing that happens is the chord gets bisected. Now that's not relevant here because I wasn't asking you anything about the chord. I'm just asking you to solve for these arcs. So the other thing that happens is we know that the two arcs, this chord, a chord is always going to cut a minor arc and a major arc. Well, that minor arc gets bisected. So the fact that this half over here is y means the other half over here is also y. And that's important because Again, we know that C is our center, so we've got another diameter. So these are semicircles. So we know that to find y, we can just do 180 minus the 128, which gives us 52. So that's y. And now actually, the rule is that this major arc here, that guy also gets bisected by, not the radius per se, but by the whole diameter. So this point here is bisecting this. So if this half is 128, then x is 128 as well. And then you're kind of done with that. This was kind of an easy one, as long as you remembered that rule that says that the radius, as long as it's perpendicular to a chord, it bisects the chord and it bisects the arcs. So let's do 6. For 6, all you gotta do is find x. But you can't really find x right away, because we said if you wanted x, you'd use x, and the vertical angle is also x, and you'd notice that one of those x's cuts this arc, but we don't know that arc, and the other x cuts this arc, but we don't know that arc. So really, what we got to do for this problem is use the arcs we do know. We know that this guy is 160, and that's cut by this angle here, called y. Let's call it y. And then we've got the 60-degree arc, which is cut by, I guess, y, because those two angles have to be the same, right? So really what we want to do is we're going to solve for x by first finding y. And we're going to use that rule that says that these kinds of angles, the ones that have their vertex in the circle, those are always going to be 1/2 of what the two arcs add up to. So we'll take the 160, and we'll take the 60, and we'll add them up and take half of the result. So that's going to be half of 220, half of 220 being 110. Now remember, y is not what we actually want. But we can use it to find the one we want, because we know that those two angles, angle x and angle y, are a linear pair, right? They form a nice straight line, so they have to add up to 180. So we know that we can find x by just doing 180 minus the y, which is 110, leaving us with 70. So that's it for 6. 7. All right, for 7, probably kind of important to notice that again, you've got the center of the circle. So this line here is a diameter. So we are chopped up again. So that'll probably be relevant. And I want A, B, and C. Okay, so I've got a central angle that's 95. That means A is 95, because central angles are equal to the arcs that they cut. So solving for A was certainly easy. You don't even have to do any math. Now we should be able to also quickly solve for B, because we can find this arc. And that arc, if we take, that arc is equal to angle B, because B is just another central angle. So this thing again is 180 minus 95, and that's 85. And so that must be B, because central angles are equal to the arcs that they cut. And then finally, C is actually an inscribed angle. So now we're back to the rule where the inscribed angles are half of the arcs that they cut. So C is going to be half of 95, which doesn't come out cleanly, but that's fine. Half of 95 would be what? 47.5? That seems right. So that's 7. Moving on. 8. Okay. This is one of the ones that a lot of people have had a little bit of trouble even just understanding what's going on. So the 72 that's printed there, that 72 is meant to be the measure of arc BD that I just highlighted. What are we actually looking for here? We just want X and Y. Okay, so how do we get there? I would say that if arc BD is 72, then that means this central angle is 72. Then we're also supposed to know, because you can read it right up here, it says point F is our center, and then it says BC is a tangent line, and B is our point of tangency. So that means this thing is a radius drawn to the point of tangency, and we already talked about that rule that says they must be perpendicular. So X is 90 right away, and you don't have to show work. It's true because we have a theorem that says so. Then they want us to find angle Y. And you got two choices for this. The easiest way to find it is probably just to recognize you've got that right triangle going on, and you already know this is 72. So how do you solve for Y? Well, you know they all add up to 180. So you know that Y plus the 72 plus the 90 has to equal 180. So that means Y is going to be 180 minus whatever these two angles add up to. Looks like 162, which leaves only 18 degrees. So that's Y, 18 degrees. That's the best way. I'll tell you the other way, just because the other way you could have gone after this problem would still be by recognizing that if this arc is 72, then this angle is 72. No, actually I don't care about that angle. Just kidding. What I do need you to recognize is that you can find arc AB, because arc AB would just be 180 minus the 72 piece. So that's 108. Then we've also got the 72. And if you look closely enough, you'll notice, whoa, that was bad, that Y is the angle formed by these intersecting secants. So don't forget, we already have a rule for this. We know that angle Y should be half of the 108 minus the 72. So if we break that rule out again, where the angle is half of the arc minus the arc, then that's going to give us a second way to figure out the measure of angle Y, because we can see that angle Y, that's our angle, is going to be half of the big arc, which is 108, minus the smaller arc, which is 72. So that leaves us with half of 36, and half of 36 is 18. So a lot of times there's more than one way to do these problems. So if you notice that you had a right triangle and you could do the problem that way, then that's great. If you instead notice that this is one of our theorems, the one about the angle whose vertex is outside of the circle, then you could do the problem by subtracting the arcs and taking half. Both of those methods are completely valid. Number 9. Aha. Number 9. This is one of those rules that I haven't talked about a bunch, and maybe we don't need it here anyway, but there's one rule that makes this super easy, and that rule is that anytime you've got a circle that has a quadrilateral inside of it, if that quadrilateral has all of its vertices on the circle, then there's a rule that says that both pairs of opposite angles will have to be supplementary. So this angle here that looks like it's about 92, you would know that the angle on the other side is 180 minus 92, so it would be 88. If this angle up here was like 120, then the angle opposite from that would have to just be 180 minus 120, it would be 60. That's automatic. That's a rule we can count on. So that means that if they want us to find W, X, Y, Z, there's 4 things to find here. Whoopsie daisy. Alright, those are all the things we got to find. And guess what? Because of our new rule, finding W sure is easy, because we know that W and 100 are supplementary. So 180 minus 100 just leaves 80. There's W. Now from there, who can I find? I think my next target here would be X, because I'm certainly recognizing X as an inscribed angle, and it cuts this arc, the one that's the 47 and the 73 together. So what does that add up to? 120. So that means X would be exactly half of that, which is 60. But now knowing X makes Y a piece of cake, because you know again that they have to add up to 180. So 180 minus the 60 makes 120. And then we have to solve for a Z. So Z is this arc. And I think the way to get that would probably be to, to notice W. W has one angle, or one side that goes out there. The other side comes down here. So we can see that W, which by the way was 80, W cuts the arc that's made out of just this piece. I guess let's make that yellow or something. So the 47, the blue cuts the arc that's made out of the yellow and the orange together. So we can certainly figure out that this whole thing in lavender is just 80 times 2, so 160. So then from there we can see that Z for us, which is only the orange part, well that would be 160 minus the yellow part, the 47. So that's 113. So Z is 113. And then that's the end of number 9. Okay, so there's another rule here that if you weren't paying attention today, you wouldn't have heard me say. But it's kind of obvious. You're being shown that these two chords are congruent because of the double slash. So I would imagine many of y'all probably assumed that if one of those chords cuts this green arc, and if the other chord cuts this blue arc, then because the chords are congruent, those two arcs have to be congruent. So that means if the green is X, then the blue is also X. And that means I now have the whole circle, because look, the green, the blue, and this big orange major arc literally make up the whole circle. So you know you can solve by writing an equation where the 222 plus X has to equal the whole circle, which is 360. So that means you've got a 222 plus 2x. And that equals 360. So that means 2x. If I subtract the 222, that leaves me with 138. Yeah, that seems right. So then you can just divide by 2, and you'll find that x is 69. So what are we solving for? X, Y, Z? So we just solve for x. It's got to be 69. Now they want Z, and guess what? We know that this is 69. We just figured that out. And I think it's hopefully starting to become obvious to you guys that Y is an inscribed angle, so it'll be half of the arc that it cut. So it's half of 69, whatever that is, 30. I'm so bad at this. 35. 34 and a half? Yeah. Okay, so that's 34 and a half. And then they want Z. And Z is just this inscribed angle here, cutting the 222 degree arc. So Z is half of 222, which is 111, which I think is an easy one. So there's that. That's 10. We got a few more to go. Here's 11. 11 should be straightforward. One thing not to do here is don't assume that this line is a diameter. It would be pretty tempting to say that, oh, there's a center right here, and so this line is a diameter. It looks like one, but it doesn't have to be, and I think it turns out that it won't be. So here's what you can say for sure. Because we've got this 40 degree inscribed angle, oh, that's so bad. We can say for sure that arc Y is 40 doubled. So it's going to be 80. And that's that green part. Notice that you've already got this blue part. It's 110. Notice that you've already got this orange part. It's 120. And then notice how it sure would be nice if you had this purple part, because you can see that X is just going to be half of that purple part. So here's where you probably better notice that if I'm looking for X, Y, we're going to call this purple guy Z, and we're going to find that first. And we're going to find it because Z, the purple guy, plus the orange, 120, plus the green arc, which is 80, plus the blue arc, which is 110. Those four arcs make up the whole circle, so they must add up to 360. That means Z, this is 200, so 310. So now you just subtract 310 from both sides and you can find that Z is 50. But remember, nobody actually asked for Z. I only asked you for X and Y. So X equals something, Y equals something. And I think we already figured out that the X, oh no, we don't know X. We know Y though. We know Y is 80. And we now know what X is, because X has to be half of the 50 that we just found. So X is 25. And then you're done. That one's done. Moving on. Okay, so this is another one showing the two congruent chords. So knowing that new rule I just gave you a minute ago, if this arc is 110, then this arc has to also be 110, because whenever the chords are congruent, the arcs are congruent too. All right, now you've got this 90, and you'd really like to have angle X. And again, if you notice, that's the whole circle. So we can write the exact same equation we wrote from the last problem. Basically, we're going to say that X, the green part, plus one of the blue parts, 110, plus the other blue part, 110, plus the pink part, which is 90. Those are all the parts, and so those have to add up to 360. So that means X plus, what is this, 200, so 310? Oh, it's literally the same as the last one. See how we got 310? Different numbers. It's not literally the same, but we actually ended up with the exact same math here. 80, 120, 110. 110, 110, 90. Okay, whatever. Slightly different numbers. This equals 360, but we still end up with 50. And so that's the arc right here. That'll be 50. So now, if you've been with me, then you know that you got a secant right here, secant right here, and those two secants form angle Y. So what's the deal? Well, we've got this intercepted arc up here, the 110, and we've got this intercepted arc down here, that's 50. So we can solve for Y, because again we know that the angle, that's not the right color at all. We know that this kind of angle, the one that's on the outside of the circle, that angle will always be equal to 1/2 of the arc minus the arc, which for us means the angle we're looking for is y. The outermost arc, the big one, is the 110. And the innermost arc, the smaller one, is 50. So I'm getting y equals 1/2 of 60, which means y equals 30. And then that's it. We needed to find x and y, and we did. So after 12 comes 13? Yeah. And so this one might be tough. Let's just get as many as we can. What do we know? Not a heck of a lot. They were kind enough to tell us that that's 50, kind enough to tell us that that's 25. Okay, let's just go from there. I don't think I'm finding A immediately, or B, but what I can find immediately is that this 25-degree angle is cutting arc G. See arc G over here? So 25 doubled is going to make this arc 50, and that's going to be G. So there, we did one thing. And now that we know, by the way, that G is 50, that means that A is 50, because A is the central angle that cuts that arc. So A is 50. What else? I would say now that you've got 50, you can find angle E, because they're just a linear pair. Can I bank on that? Yeah, I'm going to bank on that. Alright, so we'll say E is 130, because it's just 180 minus 50. Anything else we can do right now? I would say yeah. I am assuming this is a nice straight line, and I am assuming this is a nice straight line. So A and D are vertical angles, so we should be able to say that D is also 50. Okay, and now that D is 50, we can say that N is 50. And that again is just central angle out to the arc. What else can we say? This is where we start running out of theorems. There's a couple of things buried in here that we never talked about again. So how about I say this? What if I told you, now get ready for this, but what if I told you that this line was parallel to this line? That's 100% true because it's marked with the little arrows. So now you might not be shocked to find that this arc that got cut by those parallel lines, there's going to be another arc over here, and it's called H. And those two arcs, since they're cut by parallel lines, those two arcs have to be the same. So we can definitely say that H is the same as N, and we knew that N was 50. So H is now 50 also. But now that H is 50, you know that B is 50. And now that B is 50, B is 50, D is 50, everybody's 50. Alright, but not literally everybody, because we're after C. And so C and 50 and 50 and 50 and 130, those all fit around a single point. So those 5 angles should be adding up to 360. So let's figure out how that's going to go. We can say C plus the 50, the other 50, the other 50, and the 130. Those should all make 360. So that's what, 150, 280. So C is 80? Sure. Alright, where the heck's everybody else? So you're 80. We found you to be 50. What'd we do? Just never find J? We never found J. How do I find J? I assume they mean for J to be the angle formed by this radius and this tangent line. So that, of course, is just 90. J is 90. F is way the heck up here, but I'm noticing that F is looking a lot like the angle formed by a radius and a tangent line. So in case we need this idea later on, we've got this right triangle. F would be the 90-degree angle. Getting the same angle measures over and over and over here, which is fine. K and M are the only things left. All right, and M we already know because we've got C. And so C is cutting arc M, and it's cut by a central angle of 80, so M must be 80. And okay. Alright, let me explain a couple ways here again. If I've got the 50 and the 80, I could add those up. That'll make 130. And 180 minus 130 tells me that this angle is 50. Or maybe I could have just said that because this segment is a radius and this segment is a radius, we know that this triangle in blue is an isosceles triangle, and that means the two base angles had to be the same. So knowing this one was 50 does automatically make the other one 50. So you could do that by using math, or you could do that by understanding the formulas. But either way, now that I know that that is 50, you should also know that of course we still have this radius, and we are still a tangent line. So all of these angles should be 90. So okay, if that whole thing is 90 and we just found out that this piece is 50, then K would have to be 90 minus 50, which is 40. And that's everything. So if you went through every one of these problems, and if you went through every problem on the first quiz review, and if you went through all the homework in the packet, then you're probably in pretty good shape. Again, talk to me tomorrow if you don't feel like you're in good shape. See ya.